Hey everybody, this is Larry. This is me going with day 3 of the August Leetcode Daily Challenge. For August, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem subsets too. So I usually solve these live, so if it's a little bit slow, let me know what you think. Okay. The solution set, so this is just regular subset and it's 10, so you can have 2 to the 10 number of things. The solution set must not contain duplicate subsets. There are a couple of ways to handle this. We can think about how we want to do it. Let's see, return the solution in any order. So in this case, for example, you would not do 1, 2 more than once. Okay, there are a couple of cheesy ways to do it. We'll just put everything in a set and then we will be good. Mostly because I'm lazy. Yeah. So the thing that you can also do if you really clever is that taking advantage of that num sub I is between -10 and 10, and you can convert it to a base number or something like that. But at least in Python, you can do it very quickly, very easily. You can also just sort them and compare adjacent elements. Maybe that's the way I'll do it instead, because I think that's more maybe in spirit. But to be honest, I would have just did a Python and then dedupe, Python set and then dedupe or something like that. Okay, so let's just say we have permutations or subsets. As you go to a list, there are a number of ways you can do this, of course. Is everything sorted? Okay. Trying to think. If you do a subset, do you get if you sort, do you get everything sorted? I think so. Is that true? Then you only have to look at adjacent elements. Maybe that's true. So let's sort it. And then what I'm going to do is just there are a couple of ways to do power set, and that's what this thing is the power set of a set or of a list. And one thing you can do is just use Bitmask. And Bitmask is maybe kind of fancy looking, but it's not that, it's like I said, it can be intimidating, but I wouldn't worry about it. But basically the idea is that, okay, for each so what I would say for Bitmask is that what you want is kind of an array of Boolean values, right? For example, let's say nums is 1, 2, maybe just something longer, but let's start with 1, 2, 2, right? And then you can think about it as being, okay, so we want a power set where initially we want all these things to be false. And if they're all false, that means that you can convert that to a binary number for each position, and then you could add them up to be 0, right? Let's just say you have another one where you have true, false, false. This is 1, 0, 0, which is, of course, depending on which side you do it. Let's just say this is 4, though I think technically I would do it the other way, where 1 is odd, so this is actually 1, right? So then here you basically use this for every possible thing. And that's basically the idea behind a Bitmask, right? Is that you enumerate all the possible things in a cool way. So what are the advantages, right? The advantage is that you look at everything and it's a very clean, tight loop if you do it correctly. The disadvantage is that if you do it recursively instead, there are often ways that won't give you a better complexity, but will make it faster in actual practical terms because you can filter things out, pruning a lot of the branches. So these are trade-offs that I would think about, but that's basically the idea here. It's just basically a list of Boolean values compact into a binary number. That's basically the thing about Bitmask. I wouldn't be worried about too much about intimidating that, but yeah. So let's just say current is equal to a list, and then now we just go through for index in range sub n if the mask n1. So this is basically just look at the Bitmask and look at the index position, right? And basically this is saying Okay, let's say you have some binary number, Bitmask, and then one left shift by index is going to look something like, oops, like this maybe. And then if you add it, what that happens is that you just look to see if that position has a 1. If it has a 1, it would be greater than 0. If this is, oops, if this is a 0 on the other side, then this would give you a 0, right? So we just have to check that. And as long as your notation is consistent, it should be good. So if we check that this is greater than 0, then current, let's just append num sub index. And then now current is array, we just append current. And in this case, this is wrong, by the way, but I just wanted to show you what it is wrong in that we don't dedupe, but I just want to show you that this is basically it if you don't have to worry about dedupe. However, I am worrying about the internet right now or something like that because I clicked on one code and it doesn't do anything. Okay, there we go. Yeah, so this is good except for that, it has duplicates. Of course, we're trying to remove duplicates, so let's do that. Let me think about things for a second. Yeah, I guess the sorting didn't really help, which is why we test these. No, yeah, because at the very end, we just want to remove duplicates, and you can do that by just sorting this subset and then deduping it, right? How do I dedupe this? By looking at adjacent elements, so subsets without dupe. Why did they say subset with dupe? Maybe with dedupe? Okay, that's a way weird thing, but yeah, but then now let's just look at adjacent lists. Yeah, that is weird. And also just do sets of 0, say. So, yeah, okay. It has at least one element, so we don't do anything funky, I hope. But yeah. So let's just count from 1, then. If subsets of index is not equal to subsets of index minus 1, and this is pretty straightforward dedupe stuff, even though this looks a little funky, and I know that this is of n times, but I am just being lazy. Then subsets without dupe dot append subsets of index. This is standard dedupe stuff. There are cleaner ways to do it, but I wanted to write it out, and that's slightly more language not specific, because you can do this in any language. Yeah, so this looks good. I don't think I have to do any more, but let's just do one more just to see. Yeah, so did I miss something? Why isn't there a 1, 2? Dun, dun, dun. Huh. There's a 2, 1. Did I not sort? Oh, I removed the sort. I guess then that's probably okay. Possible subsets, but the order doesn't really matter. Okay. I wasn't sure if the order mattered, but I guess it doesn't really matter. So let's sort it just so we can have a better, cleaner visualization. So yeah, now it looks good, I think. At least consistent with their answer. I don't really think it matters that much either way. But let's give it a submit. Accepted. Okay, cool. So the key thing noting is that n is equal to 10. And if n is great at most 10, then 2 to the 10 is fast enough because 2 to the 10 is 1,000. And even 2 to the 10, which is 1,000 times 100, which is n squared, it's going to be 100,000, and that's very fast enough. But in terms of complexity, let's take a look. This is n log n, but it doesn't even matter because it's going to get dominated by this, which is 2 to the n times n, right? Because this is 2 to the n, this is n, and yeah. And then this is, of course, we have 2 to the n sets. So it's this times log n of 2 to the n, which of course it's going to be just n. So that the complexity, technically I think it's actually n squared, because for each comparison it actually costs O of n for each comparison. So that's basically how you get this for the sorting. And because from that, that's pretty much it, because the other one is just looking adjacent. So that is our time complexity. And for space complexity, it's just 2 to the n, because, well, times n, roughly speaking, because each of these, so there are 2 to the n at most possibilities, and each of them takes 10 space roughly. You may be able to do a slightly tighter math, but that's basically all I have. Yeah, so this is a brute force. You can do recursively. I did it iteratively. It seems pretty tight to me, so I'm okay. Like I said, you can do a few Pythonic-y stuff to be even tighter, but that's what I got. This is pretty basic. This is pretty fundamental. In that brute force is something that comes up on interview all the time, especially since they want to see how you prune, how you do recursion, how you're able to kind of get rid of some stuff. So yeah, so definitely be, confident about doing brute force. Yeah. That's all I have for this one. Let me know what you think. I will see you later. Stay good, stay healthy, to good mental health. Bye bye.